Assalamualaikum warahmatullahi wabarakatuh and good morning. We are going to present about digital signal processing assignment lab 1 basic signal operation in time domain. So my name is AININ SOFIYA BINTI HUZZANNIE B0821100028 and my team member is AHMAD AFFIQ bin MOHAMAD ASNIZAM B0821100258. And the third one is MOHAMAD SHAZNI FIKRI bin SUHAIMI B0821100031. And the last one is MOHAMAD FIRDAUS bin JAFRI B08211415. So, for the part one, we are going to present about familiarizing with simulation tools. Okay. Digital signal processing (DSP) is a specialized branch of signal processing that deals with the manipulation, analysis, interpretation of signal in a digital form. Unlike analog signal processing, which involve continuous signal, digital signal processing focuses on discrete signals that are represented using numerical values. DSP has found widespread application in various fields, including telecommunication, audio processing, imaging processing, medical imaging, radar system, and more. So the first one is about for the part one is about common signal, sinusoidal signal. So L1 is signal length number of sample. FS1 is sampling frequency for discrete time signal. F1 is frequency of 40 Hz. T1 is signal sampling interval. X1 is sinusoidal signal X1. Stem is plotting X1 with discrete sample. And X label, Y label, and title is about output signal that we want to show. So this is a output graph that we get. It's a constant signal, 19 Hz sample at 20 Hz. This one is amplitude and this is a time in value.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazni bin Salmi. I'm going to explain about familiarizing with extension tool in MATLAB. In part 1, this is a coding for part 1. This coding is have a 4 signal. X is a rectangular signal, unit impulse signal, time signal, and exponential signal. The coding for the code block for rectangular signal is LA is 20. This LA is a signal length. NA is a signal sample index. XA is a defined for rectangular signal. Let's have both side is 0 and the middle side is 1. Subplot is for use the subplot to figure into 2 multiplied 2 and have a fourth slot. So we're using plotting stem NA with XA plotting of the signal, and we label the signal with N is the X axis and amplitude is a Y axis, and with a title rectangular signal XA. For the next is signal XB. Signal XB is defined for the unit impulse signal. LB is a signal length with a 20, and B is a signal sample index. XB is a 1 at the 0, and 1 is at the LB -1. This is signal. So next is signal for FP is a sine signal. We're using same for rectangular and unit impulse signal. LC is the signal length with 21 number of sample, and C is signal sample index. ND is a phase angle per sampling period, and term is a half side of the signal. X term 1 is a flip X left side to generate the other half. XC is a combination both half and one at the center. So for last signal XD, LD and ND is the same from the other signal. LD is signal length with a 20, ND is signal sample index. Alpha is a constant. SD is a exponential alpha multiplied by ND. This is a signal for exponential signal. So we subplot this to get the result for this. This is rectangular for at the first row, and the unit sample at the second row, sine signal and exponential signal. The rectangular signal, we can see that XA is defined at the zeros both sides and 1 at the middle side. The unit impulse signal is first zeros is 1 and the others is almost zeros. That is like a scientific model. And the sine signal ST is have a phase angular that is both sides is here, and exponential signal is first the first one is 1, and this signal is have a decay that is decreased. So just for for this part.
Duration is the time span over which a signal is defined, while the period is the time for one complete cycle in periodic signal. Convolution. Linear convolution. Convolution is an operation that combines two signals to produce a third signal, expressing the way one signal influences the other. And number 8, differentiation and integration. Derivatives and integrals. Derivatives provide information about the rate of change, while integrals accumulate the signal value over time.
Okay, for start, we ask to generate a sinusoidal signal x to a and x to b with a frequency x to a equal to 300 Hz and f to b 500 Hz. And the sampling frequency of the fs to a is 5 times f to a, and fs to 5b equal to 5 times f to b respectively. Each signal is to be 0.1 in length. So you can see here this signal. This is a code, MATLAB code. Then I write. So first I declare the given which is a frequency f to a, fs to a, f to b, fs to b. With the sampling frequency L to a 5 times ff to a, L to b 5 times fs to b. So this is the output signal that I can get from the both of the signal. Then the second is to write a code in the signal from the dot wave file and mix the signal appropriately. So you can see here, this is code that I wrote. Okay, first I read the audio file with sig1 wave and sig2 wave. The signal is from on the last task here, which is you write the signal wave S2A, F2AB, because bits per sample 8, and audio write signal.wave S2A, FS2A, bits per sample 8. So with sampling rate adjustment, then from mixing the signal, which is SM sound mixing equal to S1 FS plus S2 FS. Then the last part, I make a comment to playback the sound with sound function. Sound F1 FS1 with input, then sound F2 FS2 with input, and sound SMMS input. So the output is we can listen the audio playback of the sound 1 and sound 2 and the combination of the both sound. Okay, put A. Okay, that's for the SIG1 signal, and S. Okay, that's for SIG2 wave, and the combination of the two sound is this. Okay, it's all part for me. I will pass to my friends.
Okay, I will explain about this coding. This coding is about signal processing task from the line. Okay, from rectangular signal. That line we will explain about rectangular signal Sn with a length of fs sample. This signal has a 0 on both sides and 1 in the middle. This signal is then plotted in the first subplot, and the second is sine signal. This section generates a sine signal Hn with a length of fb samples. This sine function is constructed left-right and then combined to create a symmetric signal. The signal is plotted in the second subplot. And number 3 is convolution between Sn and Hn, which Y convert as H. The code perform convolution between the rectangular signal Sn and the sine signal Hn, resulting in a new signal Yn. The length and sample indicate of the convolved signal are determined, and the result is plotted in the third subplot. Okay, for the subplot is the section use subplot to organize and display the three signal: the rectangular signal Sn, the sine signal Hn, and the result of their convolution Yn. The stem function is used for plotting discrete signal. Each subplot is labeled with the corresponding signal or operation. The x-axis represents the sample index n, and the y-axis represents the amplitude of the signal. Okay, this is the signal. The left one is the rectangular signal, which is Sn. The middle one is sine signal, which is Hn, and the right one is convolution between Sn and Hn. Okay, that's all for us. Thank you.
So the next part is about application. There are variety of the application for this lab one. The first one is about turn the audio to signal, and the second one is time scaling, and number 3 is time shifting, and number 4 is about filtering. So the first one is this coding is about to change the audio to the signal. And this to read an audio file, I use the signal and sample rate, audio rate, and I put the audio to change the signal and duration, length signal, divide by sample rate, time, line, space, zero, duration, and length signal. And this is about plot the signal in the time domain, figure, plot time signal, title, sound signal in time domain, X label time second, Y label amplitude, and grid on. This one is for the um to show the result of to show the output graph signal. Okay, so this one is about sound signal in time domain, amplitude and time invariant. So this output show us the sound signal from the audio that we choose and change to the signal in time domain.
For application of lab 1 is editing and scaling. For the first one, for the code block in MATLAB, addition and scaling example for audio signal. We're using FS is 44.1 kilo. Assume a common audio sampling rate. This is a common audio, can be adjusted as needed. Using two audio signal from the platform, hysteristic 1 and hysteristic 2. We convert this to the signal using audio read. After that, we ensure that both signal 1 and signal 2 have the same length. So we're using minimum length equal to minimum length signal 1 and signal 2. Then we add the signal and scale the result. We mix the signal 1 and signal 2 and scale the result using scaling factor of 2 and 0.5. Using time vector t minimum equal to minimum length minus 1 divided by fs. We plug the original and mix signal 1, signal 2, and signal mix signal. Then go to the MATLAB, see the result. As you can see, this is signal 1, signal 2, and mix signal. The signal 1 is small, and the signal 2 is bigger because it's scaled by 0.5. And we can see after signal 1 is adding to the signal 2, it become at the center of the signal is become bigger at the zero, become bigger, and other spots at the same block. As you can see that at the light is fs is for 44.1 kilohertz. At the MATLAB, we try to reduce the frequency, sampling frequency to the 400, because we can see if we try to reduce the sampling rate, the time become longer, and then this we use the original sampling rate is 44.1 kilohertz. We can see that the time become 1 second, 2 seconds, 3 seconds, and 4 seconds, and others. The sampling rate in this part is each manipulate the time become longer. This is example for time scaling for operation for lab 1. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, for the third application, which is time shift. So, what is time shift? Time shifting in signal wave refer to a process of delaying or advancing a signal in time. This can be achieved by introducing a phase shift to the signal. In time shift signal, the entire waveform is shifted either to the right, which is delay, or to the left, which is advanced, along the time axis. This manipulation is often used in signal processing and communication system for various purposes such as synchronization or alignment of signal. So you can see here this screenshot of my code, my MATLAB code. Then this is expected output here. So I will open my MATLAB to demonstrate it. Okay, you can see here. First of all, I turn the audio signal, which is Mr. SIG 2 from AV file to the wave file. Then I set frequency sample 1000 and set the delay amount is 10. And to shift the signal, I make a code for the zeros, column size, column original signal, and the shift signal 1 plus delay sample go to ending is equal to original sample bracket 1 and minus with delay sample. Then I plot the figure, plot the waves which is in your one figure, figure 1, subplot 211, plot time signal, title, some signal in time domain. And then the shift signal, subplot 212, plot time shift signal, title, time shift signal, and in bracket delay signal. So I will run the code. Okay, you can see here. This is the output of the signal. Above is original signal, and then the bottom is a time shift signal, which is the signal have been advanced a bit for at least 1.5 seconds. Okay, that's all for me. Thank you.
Okay, now I will explain about the application filtering. What is filtering? Filtering is generally refer to the process of selecting or excluding certain element based on specific criteria. It commonly used in various contexts such as data analysis, image processing, and signal processing. Okay, now if we can look at the slide, this is coding about filtering example with audio. If we run this coding, we will get this result. Now I will explain about the coding. Okay, if you look at the first line, Fs is represented as a sample frequency of the signal. Meanwhile, duration is represent of the duration of the signal in second. This means it will represent as a 5 second. Meanwhile, T is a time vector represent the time points in the signal. Meanwhile, in this line, it will read as an audio file. The file will serve as a SIG2 wave. In this line, it will resample if necessary. Its input signal is example as input signal Fs input sample rate. Meanwhile, this line will generate a signal with Gaussian noise add to the original signal. Meanwhile, in this line, it will specify the filter order and cut off frequency for a low pass filter. This function is to design the filter canal. And this line is to apply time domain filtering using convolution. Now this plot, now I will run the run section. Okay. If you look at here, in this first subplot, this look as the original signal, original sound. Meanwhile, in the second subplot, it will represent as the signal with noise. Meanwhile, in the third subplot, it represents as the signal with noise, but it already filter as a low pass filter.